Okay, so in this lecture, we will talk about how to process the data with data visualization. So this is in this talk, we'll talk about the matplotlib library and the seaborn. These are the two main methods actually to work on the data visualization. So this is a very basically the first thing that you should be doing once you load your data. So this is, so if you want to, understand the data, it's, best way to do it is you like trying to visualize the data. And you can use graphics, you can use tables to summarize the data and to get some good understanding of the data. So this is the, very important and the very first and a step that you should be doing once you have the data. And also, if you have some and the performance of the models, we can also using like chart images. Sometimes we can using these kind of like plot to interpret those kind of models. We will talk so very briefly how to project very high dimensional data into like just 2D and 3Ds that you can visualize it and to have a good understanding what is going on here. And visualization is like very fast way to learn something new about your data so you can have a good idea. And these are some like techniques that I will present today. So, and this is data we're going to use called telecom term. So basically this is, and the data that we have about, I believe about 3,000 like data and entries has the 20 and 20 columns, which is features. So the last column is the feature that we want to predict with is churn or not churn, right? So and everything else is just the features. So basically, it's like 19 dimensions. So if it is you are working with the numerical features, the easiest way to do is you can plot the histogram, right? So by using hist. So and using the histogram of this, you can have a good idea of those and the data. So you can see this actually has two important features. One is total day minutes, one is total international calls. If it is that, you can just do some simple histogram. You can see this total day minutes looks like a Gaussian. However, this total international calls doesn't look like a Gaussian. So this is more like skewed, and it's more skewed to the right. And also its tail is longer as well. So there's another way that you can do, which is being used and popularly, and a lot is called density plot. It's called like kernel density plot. And you can think about this is more like smooth version of histogram. So the basic way that, the advantage is if we're using the and kernel density, it's like doesn't depend on the size of being. It just, it's like more like a density curve. So what you can do is, instead of you plot the histogram, you can plot the density. So you can have a density, you have a subplot, layout 1, 2, then you can plot it like very nicely. So this is again, we're using seaborn here to do any kind of plot here. So you can see this is pretty, and so very nice. So you can see quite clearly this actually have a very, and very nice and a Gaussians and the distributions. So, and also, you can also like plot like both together. So you can have this histogram as well as this distributions overlay together. So basically this is the distributions. This is also the histogram. So you can see like two different trends here. So you can see how good this and the histogram, and how good this and density fits to this histogram. So you have some idea with that. Another very useful visualization is called a box plot. So what you have been seeing right here is I'm using the same thing. Since this total international cost and demonstrate this is not just a Gaussian curve. So that means there's some like outliers, as I can see right here. It has some like long tails. So what we can do is we can using something called a box plot. So this box plot is very, very popular and very, very useful. And you can see right here to interpret this box plot, it has a bunch of components. So this line right here is called whiskers. And there's a bunch of like dot outside of these like whiskers is called outliers. So this is just give you some idea is this box self, it just like tells you interquantile spread of these distributions. The length is actually determined, like, for example, this is like 25% quantile and 75% of quantiles. So this is actually 75 and like 25 quantile and 75 quantile. This vertical line right here is the median. So basically this is, and in this line is like 25 to 50, and this is 50 to 75, right? And this whisker to the left and whisker to the right is kind of considered as the extension of the boxes. So this is basically want to make sure this is falls into like the first quantile and minus 1.5 of IQR, and the third quantile plus 1.5 times IQR. This IQR is it's actually the width of this and Q3 and minus Q1. So this is like interquantile ranges. So this gives you some idea of you will expect most of data that should be roughly lies in this range, right? I mean, if it is Gaussian, that will be, I think it's more than 90% of data will lies into this range. However, everything else that should be on the outlier. So consider as the outlier. So you can see this dot right here. So that means there are a bunch of data points that is outside of this boxes. So this will be considered as an outliers. So this is outliers falls outside of the range boxed by the whiskers and are plotted individually on those like dots. So this is one way to do it, but of course one disadvantage is we only have very rough idea about this like 25 percentile, median, 75 percentile, and the whiskers. We don't have the information of that distributions. In order to have that kind of information, we need to have something a little more. So that means we can using that kind of violin plot, which is also very popular. So that means not only we have the information of whiskers, we are going to put this densities estimate on both hand side as well. So basically, this is the violin plot. So the major differences you can see is it has statistics that concentrate more and it has like distributions like plotted out, and rather than just the 25 and 55 and 75 percentile. But you can see there's a line in the middle right here to actually indicate exactly those key information of the box plot. So this is the top like whisker. I mean, this is bottom whisker. So this thick line here is 25 to 75 percentile. The medial dot here, right here, is the median. So this will give you the a major information that you actually needed. Other than that, it has all these distributions right here, right? So you can see this actually has to illustrate the distribution. So actually, violin plot has more information than a box plot. But of course, and sometimes the box plots can like highlight those like important informations if you need it. So both are very popular and both are being used a lot. All right, so and also what you can do is, I mean, in addition to all these kind of things, you can using this describe, and I think we have used that in an exploratory and the data analysis to describe those kind of the important informations about these numerical statistics of the distributions. For example, these are all very important, and also these are actually has a lot of information already show that in the box plot. That means we have medians, so we have a 25 percentile, 75 percentile, minimum, maximum, standard deviation, mean, and all these simple but important statistics of the distributions. So these are the something that you want to have a quick look about these features. All right, so and also this is the numerical features. So that basically, if you want to have a look at one specific numerical features, so these are the very simple tasks that you can do to see whether you can understand these features. I mean, for example, if the features is, doesn't have the shape of Gaussian, so this must be something interesting going on. For example, this total international cost doesn't fall off on this Gaussian distributions. So that means it might have some like important information that you can extract out. So there are a bunch of things that you can do here, right here. And also, other than like these numerical features, in a lot of cases, you're going to encounter categorical and binary features. I want to remind you this house sale things, and we have talked about the type of houses, could be townhouse, could be single family, could be multifamily, could be and a bunch of other stuff. So basically, these are all categories. So categories basically takes a fixed number of the values, and so basically these are all like in a category. So this is like different with the numerical features is all the informations of the mean, median, all these kind of things. We don't have it because it doesn't make any sense to take the median of the type of the houses. And also, as a very special case is with all the features in the categories and the categorical features is the binary features. So this is very important features because if the for the categorical variables, we only have exactly two possible values that just indicate we only have a yes or no or 0 and 1. So this is a very special features of the categorical features called binary features. The way that we can do, and we can do a bunch of, so we can do still some statistics, but not exactly the same statistic that you will think. And also we can still do some plot as well if we need it. So the first thing that we can do is we can plot this frequency table. So what is the frequency table is basically to check how balanced of these features if we have, like for example, the 0, 1 binary features. So here, and we can look this distribution of the target feature, which is whether this customer churns or not. So that would be only have false and true, yes or no. So that means we will get frequency tables for that. So it's very simple. We have just using this value count. That means that we only just like count how many falses and how many and trues that we have. If we do that, we find out for this churn, which is my target, and the target variables, about like 2,850 to be false, and roughly about 500 to be true. So, and you can see this actually target variable and to indicate this is imbalanced data. So because, and most of them are false, and the sum of that will be true. So this just gives you some idea. In a lot of cases, when you build models, you possibly need to consider this kind of imbalanced features, right? And imbalanced target variables. So this is something that is very, very important. And also, so this is basically by default, they're all sorted from the most to the least, so it's all like decreasing order. And you can see in our cases, the data is not balanced, and we have two target classes. One is false churn, and which is like loyal customer, and a disloyal customer is like churns. So, and you can see like basically what we see is only a very small part of the client cancel their subscription. So that means they actually churn the service. And this factor, may give you some idea. As I said, some restrictions on measuring the classification performance. We will talk about this later. If we have encountered this kind of imbalanced data, maybe the accuracy may not be the best way to measure the and how good of the model we have. Okay, the second is bar plot. The bar plot is basically a graphical representation of these frequencies. Sometimes you see it's a lot of frequency table, but it's always good to visualize it. So the way that we can do is just do count plot. It's very simple. It's basically we turn these frequencies into like basic bars. So you have false and true. You can see significantly imbalance between false and true. And also we can do this customer service calls. And we know customer service call is a categorical feature. So we can plot this bar. You can see, and most of them are concentrated as 0 and 1 and 2. And everything else it just has a like decay rate 3, 4, 5, and a decay rates. All right. And right here you can see, as I said, this is just give you some idea. Majority like customer resolve their problem in maximum 2-3 calls. But so we might be if we want to predict those kind of like any disloyal customers and which is like minority classes, we might be interested to see how like a few dissatisfied customer behaviors. So what you can do is maybe you can just like truncate these things into binary. So that means for customer service calls 0 to 3, and you can form a group that means could be satisfied. And for or above, that could be like dissatisfied. So that means they are, and they haven't solved this and their problem for more than like for like within 3 calls. So that just give you indication that they're not satisfied with the service. That further imply they might turn the services. So this is what you can tell from the story, right? So so there's a lot of things that you can tell just by looking at the features, and by looking at plot. So this is some techniques, and this is actually the soft techniques that you can do based on this. In fact, in your homeworks, and you are going to actually practice this kind of things. You are going to do some plotting, but once you do the plot, you actually need to tell me what does that mean, and rather than just give me the plot. So you actually need to write several like sentences to describe what you have seen for the plot. And also, there are a bunch of like any differences between histogram and the bar plot. It's basically histogram is and looking for the distributions of the numerical variables. However, the bar plot is used for the categorical features. So this is one of the very simple interview questions. What is difference and between bar plot versus histogram? And also the value on x-axis on the histogram is actually numerical. The bar plot is any type of values. And it could be numbers, strings, and Boolean. So basically, these are numbers. These are just like 0 and 1, which are true and false. They don't actually need to be like any numerical here. And also, this histogram is always on the Cartesian coordinate. That means you cannot change it. So the order is actually predefined for those bars. And you cannot just sort and change that by the frequencies. But if we are thinking about the bar plot, you can always order and shuffle that. A lot of cases is okay with that. But of course, for example, for this like customer service calls, it's naturally being ordered from 0 to 9. So this is like ordinal variables. The bar is usually ordered by the variable values. But you cannot just think about this like bar plot in this customer service as being histogram, because this is not it. This is actually not a histogram. So this is just a plot of the frequencies. Okay, so this is some good idea, because during these courses, I'm going to talk about a bunch of tips and a bunch of like important stuff that I want to mention in these courses. And some of these are frequent askers and frequent asked questions during data science interviews, data analyst interviews. This is obviously one of the questions that people will ask. What is differences between histogram and a bar plot? Why you should be using bar plot? Why you should be using histograms? Right. So this is a very, very important questions. So, but I want to emphasize we are not I mean, by no means cover everything in the data science interviews. This is probably cover maybe a very small portions, but you still and so you still need to go back and to review a bunch of questions, bunch of possible questions to see what is possible, like data science and interview questions in general. Okay, so I know we have talked about all these things is like univariate, and the next we're going to talk about multivariate like visualization. So that means we want to see the connections between two or more different features in one figure. So and we're not just interested in one features, we want to see like two or more features. One of the things, if I mean this actually I mean it's very important, and I already demonstrate certain part of that already in the last video. But in this video, we're going to talk about this systematically. The first thing is quantile versus quantile. So sorry, like quantitative and versus quantitative. So that means I want to check this correlation matrix among all these numerical tables. So this is very important, and the correlation matrix is very important. I want to emphasize correlation doesn't mean anything like directly, just give you these two features are highly correlated. So that means if one is up, is the other one is possible up as well. But that doesn't imply any like causality. That means, I mean, it could be just one is related, and I mean, so it could be like one is the cause and one is the root, and the as one is the cause, one is just the reasons, right? So it's like doesn't necessary to be some a deep meaning there. They just saying they have a very high correlations, so that just indicate if one is low, the other one is likely to be low. So what we can do is we can using correlations in the pandas data frames. We can and also plot that with a heat map. This just gives you a good idea of what those things look like. So one things that we have, for example, state, we have international plans, voice plans, area code, churns, and customer service calls. Right. So these are actually like non-numerical variables. They are all categorical variables. I'm going to subtract that. So the rest of things will be numerical variables. So for the numerical variables, and what we can do is we can do this kind of like correlations directly. So we can just using heat map to plot the correlations. But you can see right here, and of course on the diagonal, it should be all like ones, which is very obvious because the correlation to itself is always one. But it's more interesting to see, for example, right here, we have total evening minutes. It has a high correlation of total evening charges, which is obviously should be true because if we talk and make more phone calls, of course, the charge will be high. For example, if total international charges will be highly correlated to total international minutes, which is obviously true as well. Right? So this is, and we are using this correlation functions and just to see some very common and common senses right here. So you can see, and we said there are 4 variables. Total day charges have been calculated directly with the number of and a minute span of phone calls. So they are all like you can think about as a dependent variable because you can using all these other variables to calculate that variable, which is total day charges, basically, and you can sum them together. That means we can, and this specific features can be completely left out since they don't contribute any additional information. So let's get rid of them. So you can get rid of the total day charge, total evening charge, total and night charge, and total like international charges. These are all actually being, and it can be like map out using the total like day and day minutes, day and total and evening minutes and so on. So these are actually can be like and mapped out. So these are considered to be dependent and the variables. However, if we do this, the rest of correlation is just being pretty much close to zero. So that means they are not correlated. So, and that's good because if that, I mean, any two features are like has no correlations, so that just indicate and they are very good and to model as the as the features. And then we can scatter plot these two numerical values as a Cartesian coordinate on 2D space. So you can just scatter these two features. This just give you some idea. It looks like Gaussian here. So this is like a round ellipse right here. And you can also create the scatter plot with the C-bones and also with the like histogram right here on the marginals. So this will take a little bit while. This is just give you not only give you the scatters, it also give you a marginal on the x and the y's for each features. So they like and it both looks like Gaussian right here. And also even you can do fancier with the KDEs like marginals and rather than give the histograms. So you can, change this histogram of the kind into the KDE. So, this just give you this contour plot on the joint plot, and also the marginals is also giving you the like densities instead of scatters. Okay, so it's quite boring because you are getting like just two normal distributions, and also these joint distribution seems very uncorrelated. So because you can see this joint distribution is like ellipsoid. So that means that indicate this total day minutes and total like 9 minutes, they could be like independent, right? So they like both of that looks like Gaussians, and also like both of that looks like and the joint distribution looks like Gaussian as well. Okay, so this is something that you can do, and you can do all these kind of scatter plot. I'm not going to run this. You can run it here, and it just can get you each pair of and the variables. You can do all of that. For example, you can do all these pairwise distributions as well. It's on the diagonal. It will be and like histogram, and if it is off diagonal, it will be just scatter plot. And you can see for the most part, it looks like just a Gaussian distributions. There's something interesting right here. For example, right here, this total international cost seems has some interesting phenomena with other features, right? So it doesn't look like Gaussian distributions right here. So that means if we want to get some interesting distributions, might be this total international cost, it might be an interesting features that we can investigate more. There one more here is number V mails message. You can see has a bunch of zero here. That could be another one that we can look at that as well. All right. Another one that we can do is we can compare with the quantitative versus categorical. So this is basically one is numerical, one is the categorical features. One thing, this is very important is, in a lot of cases, this target features is categorical. So, and we want to see there's some insight between the numerical features and versus this categorical features. So what we can do is we can do something of LM plot. That means we not only can give you the scatter plot, but also we can make the value of third categorical variable to be representing the same figures. For example, if it's churn, that will be blue. That will, if it is like sort of like false, will be blue, and true will be orange. So this right here will be something that to indicate the categorical features of interest. You can see right here. So this just gives you some idea. If we're using both features total day minutes and total 9 minutes. You can see those. I mean, if we conditional on the trend to be false and condition trend to be true, these two things overlap almost each other. So that means that indicate if we're using these two features to predict whether it's a trend of like not true and true or false, it's a very bad feature. So that means we shouldn't using these two features to predict whether it's trends or not. Okay, so this is very clear things because with only these two features, these trend is not separable. It's like there's no way to separate these two things. So the only thing that we can see is there's a small portion of this like churn, like disloyal like customers, slightly toward to the top right corner. So there's a like slight trend to the right. But this is not very obvious. So this is not very clear. And these two things is and the trend is very mild. But a good reason is because like such customers may spend more time on the phone during day and time. It's not very clear. So we need more information to make this such kind of conclusions here. Okay, so we can also do these kind of like box plot to visualize these kind of two disjoint groups. So this is one way that we can do right here. So this is just give you some like and disjoint like box plotted with all the features that we have, but conditional on whether the term is false or true. So this is something that is being discussed here. So you can see whether this is features is a good features to distinguish out whether it's true or not. So these are all the numerical features, and we can see right here this total day minutes seems okay. So like it seems has a very different distributions of the for the false and true. However, for those couple of that, they look very, very close. So that means it's a really bad idea to using these features to predict the true or false. And the same as here, it doesn't look has very strong trend. It just has slight trend that if it is true, the total evening minutes, total day minutes, total international minutes is slightly more. But this is quite interesting. This customer service calls has dramatically different distributions, right? You can see right here, this churn like customers has very large and fat and the distributions right here. It tends to have a more customer service calls. And also this numbers of email messages has very dramatic changes. So that means, false, they use this kind of now and email like messages. If it is true, it's very dramatic. It's either they don't use it or they just, use that a lot. So this has give you some idea. These two features probably can help us to distinguish for the truth and false. You can see right here, total day minutes, customer service, and number of email messages. So these are three features maybe we can use to distinguish these features. So this is very helpful in feature engineering. Later on, we will talk about before you do any kind of feature engineering, that means you need to do the feature selection. That means what kind of feature you think is important. It's a bad idea to using like, for example, these features, because these features, just by looking the histogram, and with the box plotted with, and in this like two groups, you can see we cannot distinguish that. So that means no matter how you transform the data, and no matter how you do feature engineering, if we're picking these features, it doesn't seem possible to distinguish these two groups. So you should pick those features like this, and like this, and like this, who has a good, clearly has a good trend to separate these two groups. So this actually gives you some idea how to do feature selections first. And also we can do this box and violin plot to see if we have that kind of the box plot, it has this very strong and discrepancy, but it's a good idea to see. But it's also a very good idea to see what's the differences in terms of distributions, right? So, and because violin plot can give you some idea about the distributions. So here, I mean, this is just to see for the box, but you can see in terms of distributions, this total day minutes, it looks like a Gaussian right here. But for the true and for the disloyal customers, you can see the distribution is actually has two peaks. So one peak here, one peak here. So this gives you some idea. This feature actually gives you some possibility to actually separate these two different groups, okay? So that means this, I mean, if we want to build a model, this feature should definitely be included. So a very, very quick, observation is the customer actually discontinue their contract are more active users, right? So perhaps they are unhappy with, so the possible measure to prevent churn could be deductions in call rates. So they use a lot, they're not very satisfied, so they cancel their subscriptions. So we can do further. So for example, and we can just view for this, and just like we know this total day minutes is very important. And we can just visualize this interaction between total day minutes and the two categories variables in the same plot. So basically what this is doing right here is I'm going to just trying to see, so we know the customer service cost is important, total day minutes, both features are important. So we want to, but we know customer cost is from 0 to 8, for examples. So we can see under what kind of situation these two things has the most like and separable things. And you can see in the first 4, that means the customer cost is 0 to 3. This is total minute, and this is the false, and this is true. You can see most of that, and most of true actually has a higher total day minutes. Condition for the customer cost is low. On the other hand, if we see and the customer service cost is 4 to 7, that means higher, then you can see this actually have a dramatic drop right here. That total day minutes is significantly smaller than the loyal customers. So, and you can see this actually has a very strong trend to tells you maybe these two peaks actually coming from this peak right here is actually coming from the customer cost is from 4 to 7. This peak is I'm actually coming from customer cost from 0 to 3, right? So this gives you some idea first. I mean, that could be your hypothesis. You can using different other methods to actually verify or check whether, this is correct or not. So you can see from that, I'm starting with full cost. Total day minutes may not be longer than the mean factors of the customer churns. Perhaps in addition to previous guesses, there are customers are dissatisfied with the service due to other problems, which could lead to a fewer number of day minutes spent on a call. So it could be something that is they're not satisfied with other things, even though they spend a very last minutes here. There are other issues. So I mean that indicates people who are not satisfied with the service, they cancel the service. It's not just because they use the service a lot and it's too expensive. It could be some other issues. So you can see right here, these are those customers. They use a lot. They use and not a lot, but they still cancel that. These are some customers, they use a lot and they cancel the services. Okay, so these are something that is quite dramatically different. If they use a lot, they don't have a lot of customer calls. They don't complain a lot. If they use less, they complain a lot. It could be something like different. As a result, they, cancel the services. All right. At last, there will be an categorical versus like categorials. So that means, so for example, right here, so we can look at the, so number of calls to the customer service. So against this churn. So basically, if we can and do that, we can just plot this bar plot and all together. So you can see for this, you can see this is quite significant. If they cancel the service, so this is basically the distributions. The bar plot. So for the customer is loyal, this is the bar plot like this. And of course, it doesn't look very clear. So we can also look as a relationship between churn and the binary features. For example, the international plans and the voicemail plan. So this is the bar plot as well. So this is quite clear. You can see and this has a huge and a huge differential here, right here, and as well. So you can see. So that means if the international plan is enabled, the churn rate is much higher. And that means that international plan should be a strong feature. But we don't use that and a strong effect in the voicemail plans, although it does show something right here. But actually, it's not as strong as the international plans. And also what we can do, so other than just plot the bar plot, and then we can use this contingency table, which is cross tables. It just shows all these multivariate frequencies of this categorical variables. And for example, if we do this, this tells you all these churns rate and related to the state by doing this cross tabulations. So this tells you in which state and what is the churn rate. As you can see right here, and for example, in Texas, it obviously has a strong and has a larger churn rate, and the same as Washington State, they might have unusual high and a high churn rate. However, in Virginia, it has significant low churn rate. As you can see, this 72 versus 5. So this just give you some idea. These state may have some information and have some preferences for those loyal and disloyal customers. Okay. And we can also do some group by. That means, and we can just check the churn rate for each state, and you can sort that from high to low. And because right here, if we're looking this, just give you some number, it doesn't give you the rate. So it's very important that we have some idea about the rate. So that indicate like where does those like disloyal customers lies in. So you can see right here. So the lowest one is Hawaii, Alaska, and Arizona, and Virginia, as I suggested, Virginia right here. However, the highest one is Texas, California, Maryland, and all these kind of things. So you can see there's a very strong like differences for the highest rate of the churn customers and versus like not churn customers. So if a new customer comes saying, for example, if they are coming from like in Virginia, Arizona, they are like less likely to churn. However, if the customer is coming from like New Jersey, California, they might have a like high churn rate. So and this just give you maybe this state and it could be a very very important features to consider as well. And also, you want to be careful here because once we do this tabular data, and you can see these data at each state is not a lot. These conclusion is drawn based on very few examples. This is could just be some property of our this particular data set. So that means if we actually want to make sure this state has that strong like disparity here, we probably need to collect more data for this kind of things. Just couple like 50, 30 data points might not be enough to draw such like strong conclusions. But we should, definitely take this into our considerations. All right, so at last, I want to talk about data visualizations. This is very important because in practice, this kind of data visualizations is very, very important. We are usually dealing with very high dimensional data set. So that means to visualize the whole data set is very, very difficult. So in order for you to visualize the whole data set as a whole, the best way is we need to reduce the number of dimensions from very high into two, hopefully without losing too much information about the data. So this is something called dimension reduction. We're going to talk about this dimension reduction later of the courses. And this just gives you some idea, a very crude idea. If we just don't know nothing about the data, I just want to have a look about this data as a whole. The best way to do it is and something called t-SNE, and another one is UMAP. So these two features method is extremely popular nowadays in practice. So what we can do is we know, and we're gonna just leave out the state and the term features and convert to be yes or no. And also this will be, and also, and we have this like international plan and the voicemail plans map this from 0 to 1s. So this just, and everything just we can have is becomes numerical features. So you can see right here, it becomes all the numerical features. So because if it is categorical features, we cannot actually do this like t-SNE or UMAP. It has to be numerical features, right? So numerical features, you can do something about that. But if it is binary, for example, international plans, you can actually map that to 0 and 1s, and the voicemail, this you can map into 0 and 1s. That you can actually can be used to visualize the data. And also we need to normalize the data. So this is very important. We're going to talk about this normalization later of this courses. So this is something called standardization. It's very important. You subtract the mean and divide it by the standard deviations. So this can be done called standard scalar. So what we do is we're using this kind of t-SNE. And this is a very, very quick. It won't take too much time. If you have very large data set, it might take a little bit while. Again, this just gives you some like idea what kind of things you are working with. This is running. Okay. So we can just plot it out. It looks like this. So this is just 2D representation of the whole data if we consider all the features together. So you can see, obviously, we have a bunch of cluster. We have a cluster 1, 2, 3, 4, 5, 6, 6 clusters. So this is a t-SNE representation of the 6 clusters. We can actually color that with this target because overall we didn't like, and by the end of the day we want to and predict whether it turns or not. And I want to remind you, we drop out this turns, whether it's true or false, right? So we just like simply dropped out. So we can color this t-SNE representation according to the turn. And blue is loyal, orange to be disloyals. So basically, this is the color. You can see right here, this is quite a little bit confusing, but you can see, so you can see customers who churn are more concentrated in few areas right here. So this is like these 2 areas more likely to churn. So, and what you can do is what you can see is we can understand this picture by color the like remaining like binary features, international plans, the voicemail together. So you can see what those features and represented. I mean, it could be like and give you some information. Although this give you higher rate of churnings, but what does these cluster mean, right? So this is something that we want to ask. So what we can do is we can just coloring with international plans and the voicemails. For the international plans, I mean, this is extremely interesting. That indicate right here is actually international plan is true. Everything else is being false. For the voicemail, this is something like voicemail to be true and everything else to be false, right? So that indicate right here, this block has higher rate of churning rate that actually represent the blobs or the clusters of the international plans to be activated. For those 3 plot and blobs right here, this actually corresponding to the voicemail plan to be activated. Okay, so this is kind of interesting, right? So these 3 actually is the and the clusters and corresponding to the voicemail to be activated. But of course, right here for these 2, they have a higher rate of churning rate. So this actually corresponding to the international plan to be enabled. So that just indicates many disloyal customers who cancel their subscriptions are crowded together in one cluster and represent the people with international plan, but without the voice plans right here. Right here. So this is the actual ones is being clustered. So this is how you understand, the result of t-SNEs, right? So this can actually help us to understand this a lot by understand those kind of like important meaning of those clusters. So you can do the same thing for the UMAP. This is another one, very popular, very important. It might take a little while, but as I said, this is being and very popular used. Let's see how it runs here. So in general, the UMAP is slower than t-SNE. but sometimes they give you a better like result if you want. And you can see right here, we have a 1, 2, 3, 4, 5, 6 different clusters. It's much more obvious than this one because right here, although we have 6 clusters, but they are like more concentrated to each other. But for the UMAP, these like 6 clusters are much further away, and this give you a lot higher like concentrations right here for the disloyal customers right here. For these like two blobs, and you can see most of them are like loyal customers. And also we can do the same trick for the international plan and the voice plans. And you can see right here, these 2 blobs is exactly the international plans. These 3 blobs is exactly the voicemail plans. So you can see right here, this whole thing right here is actually the blobs of the so where the high churn rate is exactly corresponding to the group that has and it has international plans right here, but without the voicemail plans. So this is actually corresponding to this little blobs right here, right? So, and although this voicemail blobs, it doesn't directly give you a good indication, but there is something that we know right here. If that happened to be in this blob, that indicate so that means they also have subscriptions of international plans. That means they are more likely to churn. But for this block right here, that means they don't have international plans, but they have the voicemail plans. For those groups, they actually are quite loyal. So what is the like customer is not loyal is those group with international plans, but at the meantime, may or may not have the voicemail plans right here. So these are the 2 blobs is actually directly contribute to those disloyal customers. So this is a very simple way of data analysis to see, to tell, and to give a very rough idea and what kind of features that we should be using, and what does these features and what kind of features will contribute to this target features, right? So we are using all these kind of data visualizations to help us to make decisions, which feature we should keep and which feature we should throw away, right? And we have using various different ways, using numerical features versus numerical features, categorical features versus categorical features, numerical features versus categorical features, to actually help us to make the decisions, to tell us which features is important, which features are not important. Okay, so that's all I want to talk about today. We will continue on the next videos on like this data pre-processing processes.